surface of the sea, pressure also suddenly what happened? Decreases. Pressure is decreasing, what happening here, isn't it? When pressure is suddenly decreasing, what happened? The solubility of the gases, the dissolving of the gases in the blood also what happened? Decreases. So the gas which is present in the blood now will come outside here. Suddenly will come outside. Whatever the gas is present, nitrogen especially, isn't it? Or you can take oxygen also. But generally what happened? Nitrogen, it is not binding with blood, no. Only oxygen will bind with blood. So what happened here? They suddenly come outside here. Because of this, what happened? You may feel some type of disease, bend, a pain you are going to get, because suddenly what happened? That blood is releasing the gas molecules. So the disease we are going to get here, the impact you are going to get, that is called bend. This is important. It may lead to pain. So to avoid this one, instead of nitrogen, they may take helium here. They may take helium plus oxygen. Oxygen compulsory you have to take it, because compulsory it is for sustaining our life. Now helium we are taking instead of nitrogen. Some part of nitrogen we are taking helium here. Why? Because nitrogen and helium, if you observe, which has more solubility beta? Yesterday I explained this one. Among these two gases, which is having critical temperature Tc is what? Less. Or critical temperature is less means what happened? Less solubility, less ease of liquefaction. Now tell me better, which is what less solubility according to yesterday class among helium and nitrogen? Manjusha, can you say which one is what? Less soluble?
Yes, sir.
Which one is less soluble beta? Helium and nitrogen according to the last class. You take the table, you see the table in the textbook and you can say no problem.
Helium.
Helium is having less solubility, and also what happened? More KH value. KH is what? More, solubility is less, critical constant also less. Now even though if we go to underneath of the sea, helium solubility is what? Less. So when you come suddenly on the surface, what happened? There is no chance of what happened? Suddenly, isn't it? Gases which are dissolved in the blood cannot come outside, because helium solubility already is what? Very less. Even if you go to what happened? 1.5 atmosphere, the solubility of helium is what happened? Less only. So there is no question of what happened? This type of thing. So this is a thing actually. It's a very important beta. Okay. So actually your question is what? Scuba divers have high concentration of dissolved atmosphere gas in the blood. Why? So why the scuba divers are having very high concentration of gases in the blood? Because when they go deep into the sea, the pressure inside is very high. Under the water, the deep of the sea, under the water, the pressure is very high. Therefore, their solubility of the gas also will be more. Therefore, they are having high concentration. So the concentration of oxygen in the blood, isn't it, at deep into the sea always will be more actually. I think everyone understood this, right? Next, we will move to what? When scuba divers come to the surface, experiences a medical condition known as bend. The medical condition is not bend, isn't it? Bends, which are painful, and sometimes what happen, if the gas is releasing, what happen, that means what happen with high pressure, that case what happen, it may lead to what happen, death also. So what is the reason behind this one? Already we discussed. Again I will read out this one. When divers come to the surface, suddenly the pressure will decrease. This releases the dissolved gases. Whatever the dissolved gases in the blood leads to the formation of bubbles, because how the gases will escape from the liquid solutions beta? In terms of bubbles only. So bubbles of nitrogen in the blood. So the blood releasing what happened? Some bubbles of nitrogen. This may block actually the capillaries and creates what happened? A condition called benzitis. So this is the answer for this question. What is a scuba diver's air tank? Air tank contains now. So to prevent this dense medical condition, isn't it? How much amount of composition we have to take? So now some of the nitrogen, isn't some of the nitrogen now we are replacing with what? Helium. So helium you are taking 11.7%. Nitrogen you are taking 56% and oxygen is taking 32%. Now here, listen carefully here. To remember this one, I will explain small logic here. Anybody, Neha S is there? Neha S. Neha S. Absent. So I am putting absent for Neha S. Nidhi? 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 Nidhi also absent. प्रज्ञा?
Yes, sir.
बोलो बेटा, प्रज्ञा ऑक्सीजन मॉलिक्यूलर वेट कितना बेटा? ऑक्सीजन मॉलिक्यूलर वेट
32.
32. You got 32 here. कितना बेटा? नाइट्रोजन मॉलिक्यूलर वेट कितना है बेटा? नाइट्रोजन का मॉलिक्यूलर वेट कितना है बेटा? राधिका? What is the molecular
Yes,
weight
sir.
of nitrogen बेटा?
14.
14. Molecular weight, I'm not asking atomic weight of nitrogen, I'm asking the molecular weight of nitrogen. Dinitrogen.
28, sir.
28 है ना? 28 डबल कितना होता है बेटा? 28 का डबल कितना होता?
56.
56 है ना इधर? 56. द रिमेनिंग परसेंट कितना होता है बेटा? 56 पे रिमेनिंग परसेंटेज कितना होता है? 56 प्लस 32 कितना होगा? 58 प्लस 30 कितना होगा? 88. सो रिमेनिंग कितना होगा? 12%. In this way you can remember. Oxygen molecular weight 32, nitrogen molecular weight 28. Take double time because nitrogen will excess no. Generally nitrogen will excess no. So you can remember remaining will be helium. So this is the composition is very important. Composition is very important. You can remember like this, right? Next. Why do people living at hilltop or at higher altitude experience a condition called anoxia? Anoxia. Here if you observe, same again Henry's law, at higher altitudes the partial pressure of oxygen is less because if you go to higher altitude the pressure will decreases, therefore the partial pressure of oxygen is very less than 1 atmosphere. It will be less than 1 atmosphere. Then this leads to low concentration of oxygen in the blood. See, when you go to deep into the sea, the concentration of oxygen in the blood is more. It leads to what? Bends. When you go to higher altitudes, the concentration of oxygen in the blood will be low. It leads to what happen? Anoxia. Because of absence of oxygen in the blood. This leads to what happen? Inability to think and we can't see properly. Isn't it? Something what happened? Visibility we are going to lose actually. It may lead to what happened? Headache like that. Because of absence of excess, less amount of dilution of oxygen in the blood actually. Between ammonium chloride and sodium chloride, which is more soluble with rising in temperature? I think yesterday only we discussed this one. Ammonium chloride and sodium chloride. Yesterday only I have discussed this one. Which is more soluble with rising temperature? Yesterday only I told you this one. Yesterday I told you ammonium chloride dissolving in water. Which type of reaction beta? Exothermic or endothermic? Rani is there?
Exothermic.
Yes, sir.
So dissolving of ammonium chloride in water is exothermic or endothermic? जल्दी बोलो बेटा.
Exothermic, sir.
एक्सोथर्मिक. यहां पर क्या लिखा बेटा?
Endothermic.
तो आप स्क्रीन नहीं देख रहे हैं. यू आर नॉट वॉचिंग द स्क्रीन. क्या देख रहे हैं बेटा? एक फोन लगाकर उधर और कुछ गाना सुन रहे हैं. यहां पर क्लियरली आई मेंशन्ड हियर it is endothermic. You are saying what happened? Exothermic here. You are not watching the screen. Now yesterday only we discussed here whatever the solution formation dissolving if it is positive, okay. Now when you increase the temperature, when you rise the temperature, the solubility increases or decreases. Yesterday I have told you least shortcut principle. So when you increase the temperature, the equilibrium should decrease that temperature. The temperature will be decreased in only endothermic process. The endothermic process, forward process, the forward process takes place. Definitely what happens? Solubility increases here. In this case, solubility, in the case of ammonium chloride, solubility what happened? Increases. So what you have, even though if you don't know the concept, you are unable to understand the concept, what you have to do here? For endothermic reaction, rise in the temperature, solubility increases. And for what? Sodium chloride, it will be what? Exothermic process. For sodium chloride, when you dissolve in the water, that will be what actually? Exothermic process. Heat will be liberated. For that one, if we increase the temperature, already heat is liberating. When you heat that one, when you rise the temperature, what happens? Solubility will decrease. That is already yesterday I discussed this. Understood better everyone? This question, if they ask what happened, you have to give the answers like. Right. This thing we already discussed, I think. So I will move to what next. Already you have done the problems which are given yesterday. Which are given yesterday completed.
Yes, sir.
Right. Let me see what happened today. Some more topics we'll discuss here. Lattice energy and hydration energy. It is not there in the syllabus, but anyhow we'll discuss this one. What is the meaning of lattice energy? Because important for us. What is the meaning of lattice energy? Very simple beta. Lattice energy means the amount of energy is required to break 1 mole of ionic bonds into its constituent ions in gaseous state. So ऐसा बोले तो आपको कुछ नहीं समझ आता है. You don't understand anything here. But if I say something definition like, but if I take what happens, some type of example like, I have taken what happens, sodium chloride is ionic compound, correct or not? It is an ionic compound. Now this is in the solid state only, the crystal lattice it is. Now it is converting into sodium plus sodium Cl minus. Now here it is in gaseous state and here also in gaseous state. Now you are breaking the bond. So whenever if you break the bond, whatever it may be, covalent or ionic, you need some energy. So energy must be applied here. So how many I am taking? 1 mole I am taking. So for 1 mole of NaCl, which is ionic compound, dissociating into its constituent ions means its own ions, Na plus and Cl minus. How many? 1 mole of Na plus and 1 mole of what? Cl minus. In that case, how much amount of energy is required? That amount is called what? Lattice energy. Now here, lattice energy, is it directly proportional to solubility or inversely proportional to solubility? Better. Based upon this, if you can you say that one? Anybody can say. Lattice energy is inversely proportional to solubility or directly proportional to solubility?
Inversely.
Definitely what happened? Inversely proportional. Why? Because see, if you are dissolving NaCl in the water, you are dissolving NaCl in the water. In that case, what happens actually? NaCl must convert into its ions here. Must convert into ions here. Right? So Na plus will now surrounded by what? Water molecules. And Cl minus will be surrounded by again water molecules. Why? Because in water you have like this. H2O is there. Now oxygen will have negative character. Between these two, what happen? Bondings will take place. Coulombic forces will be takes place. Electrostatic forces will be takes place. Similarly, again in the water, if you observe H2O, where hydrogen has positive character, between these two some force of attraction will be present. Now, because of these force of attractions present between the water and cation, water and anion, some amount of energy is releasing here. Some amount of energy will be released here. That energy you are calling as heat of hydration, you are calling. Heat of hydration, you are calling. That means whenever, isn't it, when you dissolve a salt in the water or any solvent, generally in the water, some of the heat will be liberated. If that heat is more, if it release more amount of heat, what happen? It has more solubility. Now, based upon this, what I am writing, lattice energy is inversely proportional to solubility, right? And heat of hydration is also directly proportional to solubility. If you remember this concept, what happened, it will be easy for you. Now, why lattice energy is inversely proportional? Because you have to break this one. For breaking, what happened? You need energy. So if you have higher lattice energy, high amount of energy is required to convert into what happens? Liquid solution here. Understood here these two things? Next, this is actually without covering, this is no need. Evaporation, that is everything. Evaporation of patai, this is not important. For lattice energy, heat of hydration is required. Next. Now let me see the vapor pressure now. Let me discuss about the vapor pressure now. From here we'll discuss. What is vapor pressure? So what happened here? When you take what happened, I have taken some liquid here. I have taken some liquid. Okay, if it is closed one, because of external condition, liquid convert into definitely what happened? Gas molecules. I am calling that one as a vapor because it is not above the boiling point. Okay, now, so I have taken vapor phase. Now there will be equilibrium between the vapor and liquid. It is compulsory takes place. Liquid will convert into vapor, again vapor will convert into liquid because of evaporation and condensation. Now, at atmosphere condition, the pressure exerted by this vapor is called nothing but vapor pressure here. Vapor pressure. The pressure exerted by the vapor over the liquid surface here. This is the liquid here actually, where it exists in equilibrium between. For example, I have taken water better. I have taken something water. This is the water. Now I am closing this one. Why? Because if I don't close, what happens? This vapor may escape from the container. So I am closing this one. So because of external condition, because of temperature, what happens? Some of the water, here only, some of the water will convert into vapor like this. Some of the water will convert into vapor like this. Now there will be equilibrium between what happened? Water and water vapor here. Water and water vapor. Now here, what is the pressure exerted by the water vapor? At this condition, at a given temperature here, when water and water vapor both are in equilibrium, the pressure exerted by these vapors is called what? Vapor pressure here. The definition of the vapor. Generally, vapor pressure definition, nobody asked in the examination. To know what is vapor pressure, I have explained this one. Next. Different liquids, if you observe what happened, they will give different vapor pressure. But thing is that here, whichever easily what happened, having what? Otherwise, whichever is having lower boiling point. For example, I have taken benzene and I have taken water. Water boiling point kitna hai beta? Anybody knows that one? Water boiling point? अभी वो भी बोलना है आपको. 100 degrees Celsius. Correct. Very good. Benzene में बोलता हूँ इसका 80 degrees Celsius. Now, can you say which will have more vapor pressure beta? Beyond these two, benzene and water, which will have more vapor pressure?
Water.
देखो बेटा, I have taken the benzene. Here, I have taken the benzene. Okay, here I have taken water. Right? Now here, both are having at same temperature. Both are having same temperature. I am maintaining what happened here, something 100 degrees Celsius. Okay, I am maintaining 100 degrees Celsius. Now in this case, what happened? At 100 degrees Celsius, where I can get more amount of vapor? Where I can get what happened? More amount of vapor. Now tell me, you think and tell me now.
Benzene.
Benzene.
Because at 80 degrees Celsius only, benzene is converting into vapor. For water, it needs 100 degrees Celsius. But thing is that when you do condensation means what happened? Reverse. This vapor again converting into water. That is readily by what? Water. Condensation readily took place by water, because at 100 degrees Celsius, if you decrease what happened, it will convert into what here? Water. If you decrease what happened, 95 degrees Celsius, it will convert into water. But this never convert here, benzene. It need what happened? 80 degrees Celsius. So condensation first by whatever, whichever is having what? More boiling point. What I am saying actually now, not condensation. I am saying what happened about water vapor pressure I am saying. So among these two, this is having more vapor state, therefore it will have more vapor pressure. So here important thing is that boiling point of, isn't it? Boiling point of solvent if you observe, boiling point of solvent if you observe, isn't it? More boiling point, less vapor pressure. So you can write here, vapor pressure is inversely proportional to boiling point. There is a chance of getting this type of questions also, isn't it? Whichever is having more boiling point will have, isn't it, less vapor pressure in the form of a true false statement like this. Now here, let me see this reason here. The attractive forces between the molecules are different. See here, benzene and water. Benzene, what type of forces do you know better? Between benzene, what type of forces will be there? Anybody knows? Benzene, कौन सा forces रहते benzene and benzene में? और वाटर में कौन सा फोर्सेस रहते? कौन सा रहते बेटा? वनिता इज देयर? वनिता,
हाइड्रोजन बॉन्ड.
किसमें बेटा हाइड्रोजन बॉन्ड? वाटर में.
वाटर.
हाँ. नाउ इस दोनों में क्या होता है? बेंजीन में वांडर वाल्स. Non-polar. Benzene is a non-polar. Could not develop the charges. In any non-polar, definitely the forces will be what? Van der Waals force. Now, Van der Waals forces are weak. Correct or not? Where hydrogen bonding is what here? Strong. Then, which will have strong force of attraction generally in the water. So, water will exhibit what happened? Less vapor pressure. So, strong force of attraction leads to more boiling point. More boiling point leads to what happened? Less vapor pressure. Now, tell me the answer, beta. Anybody? Anybody? Lattice energy, hydrogen energies are respectively.
D.
Lattice energy will be by absorption of positive. Heat hydration energy will be released. Correct or negative? So it will be endothermic and exothermic. Answer will be what here? D. Let me discuss, continue this one, vapor pressure of liquid solution. Now here onwards, your syllabus will start up to whatever we discussed, that are basic points. Now, vapor pressure of liquid solutions when you observe here what happens. Liquid solutions are formed when solvent is liquid beta. This is very simple concept, only everyone knows. Liquid solution, how you get? If solvent is liquid, definitely will get the liquid solution. The solute can be gas, the solute can be liquid, the solute can be solid, but the solvent always will be what here? Liquid. This is general thing only. The solution containing two components beta, if it is binary solution, One solute plus one solvent actually. Now, if you observe what type of solutions you are having, liquids in liquids, solids in liquids. Why you are not taking gas in liquids beta? Because gas in liquids, the solubility I told you in the last class only is very less. So generally what happens, you are avoiding this, right? Now let me see liquids and liquids, solids and liquids. So mostly we discuss liquids and liquids only in this. Now a binary solution containing two volatile liquids. Now you see, observe here, I have made a solution with what? Liquid is solute and solvent is also liquid. In that case, they are volatile liquids. What is the meaning of volatile beta? What is the meaning of volatile? If I write what happened here, or something petrol I am writing. Petrol I am writing. And here I am writing water. Something what happened? Water I am writing. Water I am writing. Now which is more volatile beta?
Petrol.
Petrol.
Which can easily evaporate, which are having less boiling point, which can easily evaporate. They are nothing but volatile liquids, right? Now these are components 1 and 2, both are taken in the closed vessel beta. I have taken two volatile liquids beta in the closed vessel. Two volatile liquids I have taken in the closed vessel beta, right? Now here what happened? This is the liquid actually, liquid A and liquid B. Something, just imagine it is having liquid because it is a solution. So liquid A, liquid B, both are there. This is a surface area. Here they convert into vapor like this. So whatever the pressure they are exhibiting, that you're calling as a vapor pressure, right? Now, so this is the liquid phase, this is the vapor phase. How you got vapor phase beta? Because this liquid, because of external condition, is converting into what here? Vapor. Vapor, therefore exhibiting vapor pressure. Liquid exhibiting liquid pressure. Generally, liquid pressure is what happened less. But thing is that you got two phases here. One is liquid phase, other is called here vapor phase. You got it. Both the compounds vaporizes the equilibrium state established between the vapor phase and the liquid. Just now we discussed actually vapor phase and liquid phase. Both will establish an equilibrium if it is what? Closed state. If it is closed container, if it is closed system, then it is possible. We know that one already. Now let me see this one here in the binary solution here. Let me take P1 be the partial vapor pressure of the first component. Okay. So we don't know which is solute and which is solvent because how much amount we didn't add, we added actually. How much amount of benzene I have added, how much amount of what CCl4 added. I don't know that one. So we say what happened? Binary solution which is made upon by liquid 1 and liquid 2. Now in this case, the partial vapor pressure of the first component I have taken P1. Okay. Next, partial vapor pressure of the second component I have taken what? 2 P2 actually. Now what is the meaning of partial vapor pressure beta? What is the difference between the vapor pressure of liquid and partial vapor pressure of liquid? In that case, you see, I am explaining better. You see here, small letter I have taken, capital letter I have taken. Now what is the difference? This is actually vapor pressure of what? Liquid. This one is the partial vapor pressure of liquid. Partial vapor pressure of liquid. Now capital B, small p में क्या difference is? See, this is in individual beta. It is in the not mixture. Individually I have taken it. Is an individual mixture. Okay? It is an individual mixture beta. Individual it is. It is in mixture. So if I take pressure of a liquid, if I take pressure of a liquid in a mixture, that is called partial pressure. If I take that liquid individually, pure one, I am not mixing here. I have taken water. Only water. Now the pressure is called small p1, vapor pressure of it. Now if this is mixed with some benzene here, then the pressure of water is called what? Partial vapor pressure. I think everyone understood this one, right? Now I got P1 and P2. P1 is the partial vapor pressure of the first component. P2 is the partial vapor pressure of the second component. And what is P total? Total vapor pressure of the solution, right? Next. Now, the total vapor pressure becomes equal to the sum of the partial pressures of the two components 1 and 2. This is according to Dalton's law. I think we studied for gaseous molecules. If you know that, if you remember the 11th class here, isn't it? According to Dalton's law, that is for gas molecules. Here I have taken for liquid. What is actually P total is equal to P1 plus P2. It is correct only, no? For example, I am taking what happened, Devashish and Kiran. Devashish and Kiran. Devashish weight is something what happened, something for 51 kgs actually, right? Kiran is weight is something around what happened, 45 something. Now, the total weight, how much beta? 52 plus 41, correct or not? So, weight of Kiran plus weight of Devashish is equal to total weight. It also same thing what we are taking. The partial pressure of two liquids is equal to total pressure of the solution, correct or not? Very simple logic it is, very simple logic it is. P total is equal to P1 plus P2. Remember this. Next. The partial pressures are related to the mole fraction beta. According to what beta? According to which concept can you say this one? Partial pressures are related to mole fraction. Which concept we have taken now here? For this, making this note? Yes. Tamrin? Which concept you have taken beta? Now, Raoult's law let me take. Somebody is absent, I think. I'm putting absent. Listen beta. Whoever not responding, I'm not taking the attendance today. So to directly I put absent. Raoult's law. Now, what is Raoult's law? Let me see. This is very important. What is Raoult's law? Statement they're asking in examination. Let me discuss about the Raoult's law now. The partial vapor pressure. See here, I'm taking partial vapor pressure of each component in the solution of volatile liquids is directly proportional to mole fraction of its in solution. So what is different? I have taken instead of vapor pressure, I have taken partial vapor pressure. Why I have taken partial vapor pressure? Because it is a solution, it's a mixture now here. Now what I am writing here, I have taken what? Water I have taken plus alcohol I have taken. Something otherwise benzene I have taken. Okay. Now this is the liquid solution. Now the partial vapor pressure of water or the partial vapor pressure of benzene C6H6. These two are what? Volatile liquids, because they generally what happen? Volatile. Even though if you don't heat, what happen? They volatile definitely. But the rate of volatile in the water is less. Now the partial pressure of water is directly proportional to mole fraction of it in the solution. That means partial pressure of water is directly proportional to mole fraction of the water that is present in the solution. I think everyone understood this statement, Raoult's law. Yes or no? Understood or not? Understood or not?
Yes, sir.
No, sir.
Yes, sir.
No, sir. Who said no?
Sir,
So can you repeat?
Bhuvaneshwari. Listen beta. Bhuvaneshwari, please listen beta. I have taken in this container, I have taken benzene. Only hypothetical example I am taking beta. Later I will give remaining ideal solutions. I will give non-ideal solutions. Just hypothetical equations I have taken. Benzene plus what happened? You have taken water. Right? Now this is, otherwise you take alcohol, but actually what happens if you take alcohol, both will mix. That is different. Hypothetical equation I have taken here. Don't take, isn't it? Exactly like that. Now I have taken what happened when it is mixed. Now we got a solution. Now it is a solution. Which type of solution beta? Liquid solution. Correct or not? Liquid in liquid solution. Correct or not beta?
yes, sir.
Right. You got a solution called what? Benzene plus water. Okay. Now, in this solution state, the partial pressure of water. Sorry, just a minute. The partial pressure of water. The pressure exerted by water in the solution is called what? Partial pressure of water, that is directly proportional to mole fraction of water. Now what is mole fraction of water? You know that one. Mole fraction of water means number of moles of water divided by total number of water, that is number of moles of water plus number of moles of benzene. Now this mole fraction of water directly proportional to what here? Number of moles of water. Correct or not beta? Bhuvaneshwari?
Yes, sir.
Now, when you take more amount of water, if I take more amount of water, number of moles of water also will be more only. Right? Now, if I take amount of water, number of moles will be more and mole fraction also will be more. When mole fraction of water is more, partial pressure of water also will be more. Now, what I mean to say is that whatever the liquid will take here, which are not volatile beta, which should be volatile. Said no what here. In the statement, if you observe what happened, that is also important here. The volatile liquids. Non-volatile, we don't take beta. If it is non-volatile, how it convert into vapor? Is it possible? If it is not volatile, it never convert into vapor. It never give what happened, vapor pressure. So that is the reason take what happened? Volatile liquids. Now what I am saying here, so whatever the pressure, partial pressure of water in the solution is now directly proportional to mole fraction. So if it is made upon by, isn't it, two solutions, two liquids, liquid 1, liquid 2. So partial pressure of, isn't it, the first liquid is directly proportional to its mole fraction like that. Okay. Now x1, x2 nothing but mole fraction of 1 and 2. I think you understand the statement or not?
Yes, sir.
Now, so just actually it is capital P beta. Typing it is shown as a small p, but it's a capital P. No problem. If it is small p, also we can easily distinguish. If you type P naught beta, P naught, if you write what happened, this is small, you take as a small. What is the meaning of P naught beta? Very simple, vapor pressure of pure liquid. Now, so if you have a proportionality like this, what happened, you cannot do the problems actually. So relatively, we are what happened, taking the vapor pressure of the pure. For example, partial pressure of water directly proportional to mole fraction of water. Correct or not? According to Raoult's law, right? Now, I am removing the proportionality constant and putting a constant here. The vapor pressure of water, vapor pressure of pure water, pure means solvent it is, into what happened, mole fraction of water. Now, based upon this, we can easily calculate the partial pressure of water, mole fraction of water. This will be always constant with respect to temperature, because I told you in the Raoult's law, the temperature must be constant. So understood here, the vapor pressure of water, isn't it, always will be constant beta. It never changes. For example, 1 atmosphere, something you see 760 something. Just imagine that. It's never, it's a constant value. By taking the reference like this, what happened, we are calculating the partial. For example, benzene. Partial pressure of benzene means what happened, the pressure of the benzene in the solution. Then the pure vapor pressure of pure benzene now I am taking. Vapor pressure of pure benzene I am taking. Into what happened? Mole fraction of benzene. So this is the formulas are very, very important for us to do many number of problems actually. So we got like this. Now according to that law, P total is equal to what is the formula beta? P total. P1 plus P2, right? Where P1 naught and P2 naught are nothing but vapor pressure of the pure components. Pure components means before adding here. This is before adding beta. This is after adding the pressure. This is what after adding what is the pressure. Before adding what is the pressure actually. So according to the formula, P total is equal to what happened? Dalton's law, already we know this one. P1 plus P2. Where P1 is equal to, already you know this one. P1 is equal to what actually? P naught into, sorry, just a minute. P naught P naught into mole fraction of 1 plus P naught into mole fraction of 2. So this formula is very, very, very important beta to do the problems. So all of you remember this formula. One we are going to get. One more thing, already many number of times we discuss mole fraction of, if it is binary compound, if it is binary beta. This is only for binary. Mole fraction of first plus 2 is equal to 1. So if you want to calculate mole fraction of 2, 1 minus x1. If you want to calculate mole fraction of x1, 1 minus x2. If you remember 1, remember will be easy for you. In this way also you can do the problems. So this is a simplification of the formulas actually. After deriving in the formulas. Then these are the some more formulas. But no need beta. If you remember this one, then we can write any number, n number of formulas you can write based upon this. I think everyone understood here. Raoult's law formulas and everything.
Yes, sir.
Yes, sir.
इसको वेंकटेश को डाउट है? Now, from the above equations, the following conclusion we can draw now. Total vapor pressure over the solution can be related to the mole fraction. Okay, so there is a relation is there between what happened, the total vapor pressure of the solution with what, mole fraction of what, first component, mole fraction of the second component. So if I make a solution with what, benzene and water, there is a relation of total pressure with what happened, mole fraction of benzene and mole fraction of what, water actually. And the total vapor pressure over the solution varies linearly with mole fraction of the component. Why? Because see, if for example, isn't it, if this total pressure, if you observe what happened, it varies linearly, means what happened, no change in this, because if you change what happened, mole fraction of what, benzene, if I increase the mole fraction of benzene, what happened, mole fraction of water will be what happened, decreases, and total will be what, always will be same only, no. Depending on the vapor pressure of the pure component 1 and 2, total vapor pressure of the solution either decreases or increases with increasing the mole fraction of either components. Now let me see this one better. This one will be here what, actually here there is no pure, only one indicates, just take as a water here, and 2 indicates it is what here, benzene. At this point beta, only water is there, only water is there, at this point only water is there, see. Now the pressure of water I have taken P naught, because it is individual, only pure one, it is pure water, it is the pressure of pure water, it is. Now here to here what you are doing beta, here to here what you are doing, you are mixing what, benzene, you are mixing what here, benzene, you are mixing the benzene, you are mixing the benzene. Now, what happened here? The mole fraction of water from here to here, what happened? Decreasing, correct or not? Mole fraction of water is decreasing. From here to here, what happened? Mole fraction of benzene is decreasing. Benzene is at this point, mole fraction of water will equal to what? Mole fraction of benzene. So this graph, if you observe what happened, and x-axis here, this is a mole fraction data. It's a mole fraction data. At this point, pure water is there, at this point pure benzene is there here. Okay, but the vapor pressure of the benzene, obviously what happened, less, because of less boiling point, it is what, pure benzene vapor pressure, pure benzene vapor pressure, it's a pure water vapor pressure. Obviously what happened, when you have water more, then it will exert more pressure. Okay, when you have what happened here, more benzene, it will exert less pressure. In that case, the total vapor pressure less. When you have what happened, benzene is more here. When total vapor pressure, if you observe what happened here, more, because the amount of what, that benzene, sorry, water is what, more here. So this is the graph explaining what, between vapor pressure and mole fraction. Okay, so this vapor pressure depends upon what character actually. So whichever is having more vapor pressure, in that case, the total vapor pressure, if you observe what happened, the total vapor pressure always depends upon what, mole fraction of the gases. Whichever mole fraction of the gas is having higher vapor pressure, in that case we get total vapor pressure will be more actually. So these are the graphical representation we have taken. Okay, here whatever I am saying will not be valid here, will not be valid, because there are two types of solutions are there, ideal solutions are there, non-ideal solutions are there. So if you take ideal and non-ideal solution, what happen, we will get different type of graphs actually. So if you see, this one is what, P1, P2, which are what actually partial pressure of first liquid, partial pressure of second liquid, and P total will be what actually total pressures actually, right? Now this we'll discuss in the next class. This already you know this one, no? You write like this here, easily you can write here. So we'll do some problems now. Now let me take the problem now. Let me take the problem. After this problem, we can leave them. Only 2 minutes you can take now. Now, first of all, we'll see how the solution is made up on by. One liquid I have taken chloroform, CSCl3 I have taken. Second liquid I have taken what actually CS2Cl2 I have taken. CS2Cl2 I have taken. So now we got a solution now here. Now, based upon this, first of all, we'll see the molar mass of chloroform, carbon, chlorines, 119, the molar mass, molecular weight only, gram molecular weight here. Next, molar mass of CS2Cs, this is 85, isn't it? Because of 1 carbon, 2 chlorines here. Next, number of moles of chloroform, how we calculate by? Weight by molecular beta. Weight, how much given beta? Chloroform weight कितना दिया 25.5. Write down here 25.5. Molar mass 119. So how many moles you got here? 0.213 you got here. Correct? Next you will see what happened. Number of moles of CS2Cl2. Now weight of CS2Cl2 is how much given beta? 40 grams is given. So put here 40 grams here. Molar mass is what here? CS2Cl 85. So how many moles we got here? 0.47. Now based on this number of moles, can you calculate mole fraction of chloroform is possible beta? And mole fraction of dichloromethylene possible beta? Say yes or no.
Yes, sir.
Which formula
Yes,
I will
sir.
take for this one? Mole fraction of chloroform is equal to number of moles of chloroform divided by total number of moles, that is chloroform number of moles plus dichloromethane number of moles, isn't it? Now you can substitute here this 0.213 here, again 0.213 here and 0.47. I think you know this one. So we'll go to what? How to get the total number of moles here? 0.68. So no mole fraction of chloroform is equal to how much you're getting beta? 0.312 you get. Now no need to calculate mole fraction of dichloromethane. How do you calculate directly beta? Dichloromethane? Mole fraction
1 minus 0.
1
One
minus
minus
312 here. So you will get what? So you can calculate, but directly you will get what? How much here? Like. Now, what is the formula for calculating the P total? What formula beta generally we are having for calculating P total? Partial pressure of chloro plus partial pressure of dichloromethane. Now formula for partial chloroform is how much beta? P naught chloroform into mole fraction of chloroform plus P naught CH2 Cl2 into what happened? Mole fraction of dichloromethylene. Right? So now substitute here P naught. P naught is nothing but vapor pressure of pure chloroform. Vapor pressure of pure chloroform, how much they given beta? 200 they given. So you substitute here 200. Mole fraction of chloroform already you got. Substitute that one here. Vapor pressure of pure dichloromethane is given 450. Now when you substitute everything, what happened? We get the P total like this. You see, get everything P total. That is what 347.9. Got the answer now. In this way, you may get the questions actually. Should beta, right? This is about the whatever the remaining topics we'll discuss tomorrow, right? So only 5 to 10 minutes if we discuss this, it will be complete here, right? Understood? Any doubts you're having now? Tell me. No doubts?